So, hello everyone. Session number 8, application of system of equations. As I told you in the session 5 that there are many more applications of the system of equations are there. Out of that, two applications are the part of your syllabus. One is electrical network and another is road network. So we'll do it one by one example on each. So the first application, which is electrical network, for that, you should know the two laws. One is known as Kirchhoff's current law, KCL, and second is a Kirchhoff's voltage law. KCL says actually the algebraic sum of the current at any node is zero. Algebraic sum of the current is a zero. Or in simple language, we can say at any node, the incoming current is equal to outgoing current. Okay, in simple language, just for understanding. So incoming current is equal to outgoing current at any node. And the next part is KVL. KVL states that sum of voltage drop in any of the loop of the circuit is equal to supplied EMF. Okay, so we'll discuss this with example, then it becomes more clear. So come to the first question. So suppose you are given this electrical circuit. So electrical circuit should be a simple one only. What is a simple electrical circuit? A circuit in which only resistors are there and supplied voltages are there. Okay, suppose this is the electrical circuit we are given where the resistor is a 20 ohm, 10 ohm, this is 10 ohm and this 15 ohm. Voltage directions are given. So generally, if it is not given, you should assume from the directions are like this, from negative to positive, that way. So that arrows you can draw it like this. Okay. So that about the two voltages are supplied. Now we have to apply the two things here. One is a KCL and KVL. You will observe that there is node P. Here is a node P, and here is a node Q. So you can apply KCL to any of the node. You are going to get the same equation. The first thing that you will observe here is the direction of the current I1 is given here this way. So this the I1 have this direction. So here is I1 and here is I1. So I1 is in that left branch here. So here is I1. So I will take I1 here. This is the I1 only. This is also I1. So I2 is given somewhere here. This is the I2. Okay, this way. So here is also the I2. So I2 is in the middle branch only, this vertical line, that way. I3 direction is given here. This is the I3. So I3 have this direction, this direction, this direction. This is the I3. I3 is in the right branch only. So that about the currents and currents flowing through the circuit there. We can apply the KCL to the node Q here or the node P. We are going to get same equation. If you focus on the node P, see here. This incoming current is I1 and I3. I1 and I3 are coming into the node P and I2 is going out. This I2 is going out. So I1 plus I3 equal to I2, or here for node Q also you'll observe I2 is incoming and I1 and I3 are outgoing. So I2 is equal to I1 plus I3. So if you apply this KCL, if you apply the KCL at a node P, you are going to get this equation I1 plus I3 equal to I2. That means I1 minus I2 plus I3 is a 0. So this is the equation number 1. Okay, that is equation number 1. Now the next part comes is we have to apply now KVL. So KVL we apply to the loops of the circuit. So to apply this KVL to the loop of the circuit, there is one important thing that you have to take it, the direction of loop. Now you can take the direction of loop clockwise or anti-clockwise, anyone, but generally I prefer to take the direction of loop with the direction of voltage. So this is the direction of voltage, so I taken the direction of loop in that way only. What is the benefit of that? When the direction of loop and the direction of voltage are same, so we consider the positive AT plus AT as a whole. If we take opposite direction, we have to take minus AT. Not only that, the direction of loop and the direction of current are matching, then the voltage drop created is also positive. That is, here across this 20 ohm resistance, the voltage drop is 20I, because if R is a resistance, I is a current, V is equal to IR. V equal to IR is a formula. So voltage drop across this resistance is a 20 I1, 20 I1, and that is plus 20 I1 because the direction of current and the loops are same. So just apply the KVL for this left loop as well as for the right loop. The right loop direction I will take clockwise and here is anti-clockwise. Okay, you can take any directions. At the end, you are going to get the same equation. So if you apply, suppose you are applying it for say this uh, right. Let us start with left loop. Okay, left loop only. So for left loop, this is the 20 I1. 20 I1 is the first voltage, then equal to 80 only, and here is one more, so 10 I2. So 10 I2, 20 I1 plus 10 I2 is equal to 80. This is the equation we get for the left loop. For the right loop, yes, here is a 10 I2. 10 I2 is a voltage in the right loop also, but here is a 10 I3. Not only that, here again 15 I3. So 10 I3 plus 15 I3, we can write it as a 25 I3 equal to supplied voltage, that is a 90. So that way we are getting the three equation. This is the first equation. Okay, so I'll rewrite all these equations again. That I show you first. So when you apply the KVL now, KVL for the right loop is 10 I2 plus 25 I3 is a 90, and left loop is 20 I1 plus 10 I2 is equal to 80. Now the remaining part is so simple. Our aim is, the question will come in the exam. This diagram will be given. This diagram will be given. This data will be provided, and the question will be find the amount of current. Find the amount of current passing through the circuit. Indirectly find the values of I1, I2, I3. That will be our question. And now to get these values of I1, I2, I3, we have the system of three equations for three unknown. We'll go in the row echelon form and we can easily find out the solution of that system. So for this, yes, obviously we require this equation. So I'm just noting this equation. The first equation I will take as I1 minus I2 plus I3 equal to 0. That is the first equation. Next equation is, you can take any one. The second equation, either this or that. So okay, I will go this way only. Uh, let I take 10 I2 plus 25 I3 equal to 90, and the last equation is 20 I1 plus 10 I2 is equal to 80. So with these three equations, now we are going to solve this system of equation. First, which matrix we should write? Just matrix A or augmented matrix? Which type of the system is here? This is the system of non-homogeneous, because RHS are not zeros. 90 and 80 are there. So this is actually a non-homogeneous system. So we'll start with, consider the augmented matrix. Consider the augmented matrix A colon B. For this augmented matrix A colon B, the first row is 1, minus 1, 1, 0. Next row is 0, 10, 25, 25, 90. And the last row is 20, 10, 0, 80. So this is the augmented matrix A colon B. Our aim is to reduce it in the row echelon form. We'll use A11 and we'll make these two zeros. So only one transformation we require here, and that is say R3 minus 20 times R1, and we get 1 minus 1 1 0 0 10 25 90, and here are the zeros. Now this is 0, so R3 minus 20 R1, so this is a 10 plus 20, it's a 30, 0 minus 20, and here 80 as it is, no change. That's one. Now we focus on column 2. With the help of A22, we'll make the zeros below it. That's a row echelon form. And again, a very simple transformation we require here, and the transformation is R3 minus 3 times R2. So 1 minus 1 1 0 0 10 25 90, and here is 0 0. Now you'll observe here is R3. R3 is minus 20 and minus 3 times minus 3 times, so minus 75, minus 20, minus 95, and here is 80, minus 270, so I think it is a minus 190. You check. Okay, this is a 1 minute, I will check it. So 93s are minus 270, minus 270 plus 80 plus 80 It's a minus 190. That's correct. Okay. So that is the end of row echelon form, because this is A11, this is A22, A33. Below main diagonal, everything is a zero. Everything is a zero. So we can say the rank of A is a 3 equal to rank of AB. Number of unknown, that is I1, I2, I3, that are also 3. So unique solution. We have a unique solution. And to get that unique solution, just we started from equation to the matrix. Now from the matrix, we should write the equation. What is the first equation we get? I1 minus I2 plus I3 is a 0. That is the first equation of this row echelon. Next equation is a 10I2 plus 25I3 equal to 90. And third equation, minus 95I3 equal to minus 190. So this last equation, if you check it here, I3 equal to 190 upon 95. So I3 is a 2. I3 is a 2. So we got the value of I3 from the last equation. We have to substitute in this second equation now. So if you replace I3 by 2 here, you can cross check. It becomes 25 into 2 is a 50, 90 minus 50 is a 40, 40 by 10 is 4, so I2 becomes 4. I2 is a 4. This is by second last equation. Now I3 is 2, I2 is a 4, and if we replace in this first equation, we get I1 equal to 2 again. So that is the end of question. We got the values of current, which are 2, 4, 2. In particular, if you want, you can add the unit of the current also, like 2 ampere, 4 ampere, and 2 ampere. These are the values of the current flowing through the circuit. So whatever the circuit we are given, in that circuit, the currents are 2 ampere, 4 ampere, and 2 ampere respectively. So this is the way, yes, we can apply the KCL and KVL. We can create the system of equation first. Once we get that system of equation, we can solve it by a row echelon form, and we can get the values of current. So that about our first application of this is the application of system of equation, in particular non-homogeneous equation, to the electrical circuit. Here is a second application. The second application will be like this. Find the traffic flow from the following figure. Means indirectly, whatever the diagram we are given, this diagram is of the traffic flow network. So in this network, all these roads are one way. You'll observe from this position to that position. So all the vehicles are moving on in one direction only. Whatever these numbers represent, that shows that, like here 300 vehicles are at this position, 500 are at this position in that direction, 300, 500, and so on. Not only that, in between some variables introduced, say x1, x2, x3, x4, and these are unknowns. These are unknowns, and we have to find out the number of vehicles which are present at these positions, So that also we can find out by the system of equation. So the most important thing is formulate the equations, and there is very simple rule to get the equation. At any position, at any node, number of vehicles coming towards to that point are equal to the number of goings away from that point. It is exactly similar to KCL. Here we have to just say incoming vehicle equal to outgoing vehicle. So at a point A, if you observe at a point A, 300 are coming in, 200 also coming in, 500 are incoming vehicle, and X1 and X4 are outgoing. So X1 plus X4 is, that is a outgoing vehicle equal to incoming, which is 500. So that is a point A. So if you come to the point B now, so for the point B, x1 and x2 are incoming. So x1 plus x2 is equal to 800. At a point C now, this point. So x3 and x4 are incoming, and that is equal to again 800. And the last at a point D, which is this last point, where x3 and x2 are outgoing. So x2 and x3 are outgoing, but is equal to 1100, which are incoming. So 600 and 500 are incoming. So this is main step only. So if we able to convert the given data in terms of the system of equation, the remaining part is just augmented matrix and a solution. Okay, now we'll move to the solution here for this non-homogeneous system again. These are how many equations? 4 equations in 4 unknowns, x1 to x4. Okay, so that is our system of equation that we have. So our aim is to just write the augmented matrix first, A. So let I write here. I will check if the space is not enough. I will erase that side. So let the coefficient, not coefficient, let augmented matrix A colon B. Augmented matrix A colon B is equal to the first row. See here, 1 0 0 1 is equal to 500. Second row, 1 1 0 0 800. Third row, which is a 0 0 1 1 800, and the last row is 0 1 1 0 1100. Where to focus? Obviously the first column. First column, with the help of A11 we want the zeros in the first column below diagonal. So a very simple transformation, R2 minus R1. So by R2 minus R1, if I do this transformation, the matrix become equivalent to 1 0 0 1 500 as it is. The next R2 minus R1 is there, 0 1 0 minus 1 300, and remaining as it is 0 0 1 1 800, 0 1 1 0 1100. That's one. Now the next focus is on the column 2. With the help of A22 we want below zeros, so very simple transformation, R4 minus R2, R4 minus R2, and we get the next matrix like this, which is 1 0 0 1 500. Here is a 0 1 0 minus 1 300, 0 0 1 1 800, and here we have 0 0. So here R4 minus R2 is there, so 1 minus 1 is 0, so 1 as it is. This is plus 1 now, and that also comes 1100 minus 300 is 800. You will observe one more step is required. One more step is required. With the help of A33 we have to make this 0, and very simple transformation, R4 minus R3. When you perform R4 minus R3, this last row goes to the 0, is it? So the last echelon form that we are going to get it here is this one, 1 0 0 1 500, then 0 1 0 minus 1 300, 0 0 1 1 800, and here is the zeros, all zeros. That's one. What is the rank of A? You'll observe 1 2 3, three non-zero rows are there. Rank of A is a 3, equal to rank of AB, but the number of unknowns are x1 to x4, so which is less than unknown. So we have infinite solution. We have infinite solution. Let I erase these equations so that I can write a remaining solution there. So important thing, we come across infinite solution. And how to get this infinite solution? We will write these equations back again. First equation is x1 plus x4 is 500. Second equation is 0x1, this is x2 minus x4. x2 minus x4 is 300. Third equation is x3 plus x4 is 800. That's one. Only 3 equations and 4 unknowns. So always we start with the last variable as parameter. Let x4 is a t. Let x4 is a t. If we replace x4 equal to 2 in the this last equation, so it gives us x3 equal to 800 minus t. Same x4 if I replace in the second last equation, x2 equal to 300 plus t, and the last, if I replace this t here, x1 becomes 500 minus t, and you will observe we got the solution in terms of the parameter t. So for the traffic flow network, there are infinitely many solution. Everything depends on the value of x4. Suppose the number of vehicles at x4, that is t, then these are the number of vehicles at all other places. For example, if t is a 0, you will get the remaining vehicles at remaining positions there. whenever you put actually t equal to 0, it indicates number of vehicles are not there, not a single, so that means that road is closed. Okay, that way also sometime question comes, what happens if we close the road at that position? So that means t is a 0 there, and you will get, then you should say that the number of vehicles, you get a unique solution, and that unique solution is this number of vehicles at that different positions there. Okay, so that about your last application. Second application of system of equation means part of your syllabus is a traffic flow network. Okay, so that about your session 8. Thank you.